This is OpenNMS 101, Module 13, Part A, Introduction to Provisioning. Previously, as in the Passive Status Keeper module, provisioning has been glossed over as it was not the focus of the module. This module will focus on provisioning. The introductory framework for provisioning is covered in the Horizon Operation Quick Start documentation under Step 3, Provision Inventory. The steps in this tutorial include creating the nodes as VMs, configuring OpenNMS to access the nodes through SNMP, creating a requisition for the nodes. A requisition is a set of nodes having a similar network monitoring profile, and configuring and executing discovery. To create the nodes, create a single node as a VM, install Rocky Linux on the node, install the SNMP packages on the node, create the SNMP v3 user, extend SNMP, test the extensions locally, open port 161 on the node, then clone the node into 3 other VMs. Then test each node's SNMP extensions from the OpenNMS server. In this tutorial, the OpenNMS server expects to have 4 nodes to work with. 192.168.159.106 will be Denver.local domain. 192.168.159.107 will be Sacramento.local domain. 192.168.159.108 will be New York.local domain, and 192.168.159.109 will be New Orleans.local domain. The VM configuration is straightforward. 2 GB of RAM and 20 GB of storage. Rocky Linux's minimum installation storage requirement is 10 GB. The steps that follow are not new to this video series. The commands are provided in the node setup.txt file. Install SNMP as directed in this slide. Enable SNMP and check its status. Add the SNMP v3 user. The auth password, privacy password, and username are similar to those used on the OpenNMS server. The differences will highlight a new configuration parameter in etc/snmpd.config.xml. One can compare the SNMP walk version 1, 2C, or 3 outputs. Eliminate the v1 and v2c users access. Add the extensions developed in the service assurance and data collection modules to the node. Test those extensions. This is the content of the /etc/snmp/snmpd.conf file. Note that SNMP v1 and v2c have been eliminated by removing the relevant COM2SEC line. Open port 161, that is the SNMP port, and verify that it is open. Clone the VM 3 times. VM number 1 should have the host name Denver.local domain. VM number 2 should have the host name Sacramento.local domain. VM number 3 should have the host name New York.local domain. VM number 4 should have the host name New Orleans.local domain. The IP address can be configured by accessing the network configuration on each node. Select Wired Settings. In the dialog, click on the gear icon under Wired. Select the Manual IPv4 method. Click on the IPv4 tab and fill in the address, netmask, gateway, and DNS server. Your entries might vary. When done, click on Apply. Turn off and then turn on networking. This was done on each VM node with these results. Denver.local domain has the IP 192.168.159.106. Sacramento.local domain has the IP 192.168.159.107. New York.local domain has the IP 192.168.159.108. New Orleans.local domain has the IP 192.169.159.109. This is a screenshot from the OpenNMS server performing an SNMP walk against each of the node's NS extend output to table objects. This completes the setup of the nodes. Time to get back to OpenNMS. To configure OpenNMS's access to SNMP on the nodes, edit etc/snmpd.config.xml. Copy and paste the current definition line and replace the security name, auth path phrase, and privacy path phrase as appropriate. Instead of using specific addresses, use the parameter range. From the command line, change directory to /opt/OpenNMS/etc. Backup snmpd.config.xml. Edit snmpd.config.xml. Copy and paste the definition line. Replace the security name with node admin. Replace the auth pass phrase with uppercase N 0D3 auth pass. Replace the privacy pass phrase with uppercase N 0D3 priv pass. Add the range of IPs related to the just created nodes. That range is 192.168.159.106 to 192.168.159.109. Save and close the file. In the GUI, access admin configuration and click on Configure SNMP by IP. Enter the IP address 192.168.159.107 and click on the lookup button. The SNMP v3 communication parameters should display. To create the requisition for the new nodes, use the Manage Provisioning Requisitions configuration page. Create the tutorial requisition. Clone the detectors and policies from the self-monitor requisition to the tutorial requisition. Edit the tutorial requisition and keep only the ICMP, SNMP, SSH, and tutorial-monitor detectors. From Admin Configuration, click on Manage Provisioning Requisitions. Click on Add Requisition and enter Tutorial for the requisition name. On the Self-Monitor line, click on the far right button and select Clone Detectors and Policies. The target foreign source is Tutorial. Click on Clone. Click on OK. The cloned detectors and policies will override those currently in Tutorial. There are none in Tutorial as of yet. Click on the pencil button on the tutorial requisition line. Then, click on Edit Definition. Remove the following detectors: OpenNMS-JVM, OpenNMS-DB, OpenNMS-DB-Stats, SMTP, OpenNMS-PSM. That was the page sequence monitor. Verify there are no policies. Save the requisition. Click on Return. Click on Synchronize, Scan All Nodes, and Synchronize. And then click on Return. The requisition has been added. The tutorial monitor was created in the Service Assurance module. It was created in the poller-configuration.xml tutorial package. That package was limited to the IP address 127.0.0.1. That will have to be changed to include the new node's IPs. Change directory to /opt/OpenNMS/etc. Edit poller-configuration.xml. In the tutorial package, add a range that begins at 192.168.159.106 and ends at 192.168.159.109. Save and close the file. Reload the pollerd daemon. In this tutorial, discovery configuration requires selecting a requisition and a range of IPs against which to run a scan for that requisition. The range is 192.168.159.106 to 192.168.159.109. Per the OpenNMS documentation, once discovery has been configured, return to Manage Provisioning Requisitions and sync the requisition, scanning everything. Click on Admin Configuration. Configure Discovery. Select the tutorial requisition. Scroll down and select the range 192.168.159.106 to 192.168.159.109. Click on Add. Click on Save and Restart Discovery. Click on Return to the Admin page. Then click on Manage Provisioning Requisitions. On the tutorial requisition line, click on Synchronize the tutorial requisition. Select Scan All Nodes and click on Synchronize. Refresh the page. 4 nodes are now defined in the tutorial requisition. After a few hours, the service availability graphs are showing well. Tutorial-monitor is up, which means that the poller-configuration tutorial package modification worked. Flipping to the resource graphs and looking at the SNMP extension tutorial collector random number generator and narrowing the time period to 2 hours also shows well. To summarize discovery, nodes with SNMP agents exist in the target network. The nodes need to be accessible to the OpenNMS server via SNMP. OpenNMS needs to be configured to access SNMP on the remote nodes. A requisition should absolutely be created and linked to individual addresses, URLs, or IP ranges. Discovery is configured and executed. Discovery occurs on a repetitive basis. The first drawback to discovery relates to the association of a requisition to an address, URL, or address range. While easy enough to do in a tutorial, this may not be possible in the real world. Drawback number 2. One should never scan an entire private 10.star network. Never. Just do not do this. Think of timeouts and retries. Do not do this. The IP range element needs to be reasonable. It is better to use an in-house inventory, standalone provisioning system, or a DNS server to directly provision nodes. The tools that can do this will be explained later in this module. First, tutorial-based provisioning preliminaries need to be covered.